Okay, YouTube, in this video we're going to specifically work on converting from polar coordinates into rectangular coordinates. In our last video what we did was we had related this point r theta to the point xy, and certainly they are the same point, but kind of discovered how r and theta are related to x and y. And so here's what I want to do. I want to kind of highlight in this table a couple of things here. These first two formulas we are going to use when going from polar to rectangular. So use when going from polar to rectangular, and that's what we're going to do in this video here. But you can see that basically if we know the values of r and theta, we could work backwards always to find the value of our x here. So one thing I do want to mention is this: you should always draw a picture. So always sketch the point first. Sketch your point first. Okay, so let's go ahead and take a look at using these to begin with here. When going from polar to rectangular, knowing r and theta, looks like to convert from a point from polar coordinates, r theta, to rectangular coordinates, all we really need to do is use the formulas x equals r cosine theta and y equals r sine theta. So in this first example, what we are told is that our r value is 2 here and our theta value is 3 pi halves. So to begin with sketching what this looks like in the first place, we would know that we're going in a 3 pi halves direction and that we're going 2 units out from the origin or from the pole in that direction. And so we would say that this is the point 2 comma 3 pi halves. Now what we want to do is find this in xy form here. And so you could see that drawing a picture, if I said what point is this in xy form, you would have to be crazy not to be able to tell me that this is the point 0 comma negative 2. Because let's face it, looking at this, obviously in xy form it is 0 left and right and down 2 from the origin. And so one thing I want to kind of write right here is this: we get the point 0 comma negative 2, and this is the rectangular form of this point right here. Now in terms of finding this, how we could have done this, the way we're needing to be using is our formulas here. So graphically we used common sense. Using our formulas here, let's take a look at this. We have r cosine theta for x. So we would get this here. We would say our r in this case is 2, and we have the cosine at 3 pi halves. And so what do we know about our cosine value at 3 pi halves? That is to say, on the unit circle, what's the value of cosine down here? And we can see that our cosine value is 0. So really what we get here is 2 times 0, or 0 is our x value. Now looking at our y value, we would say that this is r times the sine of our angle here. And so our r value, 2, times the sine of our angle, or our argument here, which is 3 pi halves. Our sine value at 3 pi halves, looking down here, and this is supposed to be a negative 1 here, but we'd say is a negative 1. So we get 2 times negative 1. But really we end up with a negative 2. And so really what I need everybody to see here is that we did end up with our x and our y being 0 and negative 2. And we can do this both algebraically and graphically. So our point here in rectangular form is 0 comma negative 2. Now looking at this next point here, negative 8 comma pi thirds. Let's go ahead and start by getting a sketch of what this might look like here. And so we know that r is negative 8, so we're going to be walking in an opposite direction, and that our theta is pi thirds. So to imagine this here, pi thirds kind of lies in this direction right here. We would actually have to walk back 8 units in this direction here. And what I'm going to do is I'm just going to select this point right here, and I'm going to say that, look, I know that this r value here is 8, or at least it's negative 8, but I know that my r value is a distance and always positive. So that negative only matters because we walked backwards from our pi thirds direction right here, pi thirds. Okay. Also what we know is that this angle right here is our direction angle really. So when we look at this here, we say, okay, well, how is this related to x and y? What we're going to be doing here is taking r sine theta and r cosine theta for our y and our x respectively. And so you could see that if really what we were looking for here was the value of x and y, we could at this moment use our angle here that we see, and this is a 4 pi thirds that we see here. But we could say, we could work backwards here using reference angles instead, which would be a pi thirds or a 60, and just use SOHCAHTOA. So that is to say, we could say that the sine of pi thirds, okay, or sine of 60 here would be opposite over adjacent. So we get y over 8, and you could see that y equals 8 times the sine of pi thirds. But what I want to encourage you to see is that this really is r times the sine of theta. So again, really sketch out this picture. We could use SOHCAHTOA to do it, but really what we want to be doing is that saying that 8 sine of pi thirds really is our value of our y here. So we say, well, what is our sine at pi thirds, or 60 degrees? Well, we know we get a sine value at 60 degrees of root 3 over 2. And so to multiply these out, I suppose putting our 8 over 1, we get this to be a 4 and this a 1. And multiplying straight across, we get 4 root 3 over 1, or 4 root 3 is our x value, or our y value, pardon me. So for our x value, which we haven't found yet, we say r times the cosine of our angle here, pi thirds. And so our cosine at pi thirds, fabulous, is not going to be root 3 over 2, it's going to be the half. And so we would say get 8 times a half, which certainly is 4. And so our point in rectangular coordinate system, our point -8 comma pi thirds, I'm going to write this down, -8 comma pi thirds in polar, is in rectangular form. This point here, our x value is 4 and our y value is 4 root 3. And we could see that on our picture over here. So what I want you to do at this point is kind of pause the video here, and what I want you to do is come up with the rectangular coordinate form of these 2 points that you see up here. And once you get an answer, go ahead and hit play on your video here. If you are ready for your answers, let's go ahead and take a look. We would say that this first point here, if we're sketching it, is in a pi direction and we're going out 3 units from the origin. So since pi faces in this direction, we're going 3 units away. We would say that this right here is our point 3 comma pi. Likewise, though, we could clearly see in rectangular coordinate form, this would be just -3 comma 0. So I'm going to go ahead and write that right now. But also what I want to see everybody to have done, I want to see that you've done, is that you took your r value here, 3, and for your x value, we took 3 times the cosine of theta. This would be 3 times the cosine of pi. And our cosine value at pi, right here is -1. So what we get is 3 times -1, which is really -3 is our x value. Now for our y value, which should certainly be 0, the reason why is because we're taking 3 times the sine of pi, and our sine value at pi is 0. So we get 3 times 0, and so we get 0. So our xy pair is -3 comma 0. Now looking over here at -10 comma pi sixth and sketching this out, what we would have gotten is in a pi sixth direction, which is kind of like a 30 right here. Here's our pi sixth. What we're going to be doing is we're going to be going 10 units in the other direction. And so I'd say, here's the other direction right here. And I would say that this is the point -10, walking backwards, comma pi sixth. And so using this right here, we could say that we know our r is 10, and we know our reference angle here is a 30-degree reference angle, or pi sixth. So we can work backwards to solve for our x and our y here. To play it safe, however, what we want to do is just not graphically, but algebraically, we would say r times the cosine of theta here, pi sixth, and then our y value would be our r value times the sine of theta, which is our pi sixth here. So going through and evaluating these, we say this is -10 times the cosine at pi sixth, the cosine of a 30-degree angle right here. Our cosine value should be root 3 over 2, and our sine value is a half right there. So we would get root 3 over 2 for our cosine value at 30, and we would say with cancellation here, we get a -5 here and a 1 here. Really we end up with -5 root 3. And for our sine at pi 6 here, we get a sine value of a half. So really half of a -10 is a -5. So our point here, -10 comma pi 6, in rectangular form, would be the point x value wise, -5 comma root 3. And the y value wise, -5. So you could see going left, -5 root 3, and down, -5 would get us to this point here. So in the next video, what we'll do is we'll look at how we could go the other way and convert from rectangular coordinates into polar coordinates. Cheers.